Hey everybody, this is Adam from Tungsten Amplification. Welcome back to my workshop. Today we're going to talk about the Dynaco ST-35 again. It's been approximately 1 week since I last made a video and quite a bit has happened. Let's start with the power supply. On the stock Dynaco, we want 385 volts at that first filter capacitor. If I plug in amp number 1, which is my stereo, straight into the wall, I'm going to end up around 430, 435 volts, which is a bit more than I'd like to see. So after racking my brain, trying to figure out what I could do, putting some Zener diodes in and watching them release the magic smoke, I came up with this. And this is a power box, which is by no means the first person to ever think of this. Plenty of other people have done something similar. You're probably familiar with something called the brown box. What this does, it's got a switch on the front and an indicator light. On the back, you plug it into the wall. It's got an AC outlet where you plug in your stereo or your vintage guitar amplifier or your Hammond organ or whatever. And it's got a fuse holder as well. And what it looks like in the real world is this. There's your front panel, the power switch, indicator light. Here's your back panel with your fuse holder. This is your power cord. This is where you plug in your amp. Because my Dynaco amp has a 368 volt power transformer, and we really want 335, it's best if I run mine at 105 volts AC instead of 113. In the future, when I make these boxes, they'll have a 113, 117 switch on the back, which will allow you to get a couple different voltages. Inside, it's not too complicated. Got your hardware, got your transformer, got a terminal strip, more hardware. Does the job though. And it means I don't have to run the stereo or anything on a Variac. I can just plug straight into that box. You can leave your stereo power switch turned on all the time and use that box as a remote power switch, which is kind of cool. And of course, they each have a 10-foot power cord, so you could have, quite a bit of distance between them. But that's not really all we're here to talk about. We've got a schematic in front of us. We're going to talk about that. Where do we start? This started off as a stock Dynaco ST-35. As you know, from the moment I turned it on, I had horrible oscillation, which led to me removing the entire negative feedback loop and the positive feedback loop and this little spur here as well. We added grid resistors, 1K on this side and 100 ohm on this side, to both of the power tubes in each channel for better stability. For a while I had a snubber capacitor resistor set up on the plate of the phase inverter, but I took that off today. And there is a slight difference as far as treble response with it in there. It damps like maybe above 18 kilohertz, but it sounded better today with it out. So I took it out. The one thing that kind of perplexed me as I was playing with the stock Dynaco circuit with no negative feedback and the aforementioned changes was that with certain CDs, especially CDs, but if you turned up your phone too much, if you were casting into the machine, there was a lot of gain, and the amp would actually go into distortion, like guitar amplifier power tube distortion. It may have been phase inverter distortion. This amp has a cathodiene phase inverter, similar to the Tweed Deluxe and many other classic Fender amplifiers. And those are known to get some blocking distortion. I can't really discern by ear in this stereo whether that was blocking distortion or just overdrive. Doesn't really matter. My attempt to fix that was to look at this 300K plate resistor on the first gain stage. The 1.3K is not an outrageous value, but 300K is about 3 times what you would expect to see for a 12AX7 style triode. That led me to draw some load lines, which is not something I normally do, but it made sense to do in this situation because I'm trying to learn. So let's zoom in just a touch on that. So the purple line is with the stock 330K resistor. It's very low, right across the curves. My understanding, based upon my research, is that that means there's a lot of gain there. This part up here, more linear, less gain. So my first step was to go to this red line here, which is a 100K plate resistor. I pulled out the 330, put in the 100K, and when I fired up the stereo, it sounded kind of weak, a little bit anemic, actually. Instead of just getting distortion at, a third to half volume on loud passages and loud discs, I could crank them up 3/4 of the way, maybe all the way, and get a pretty clean signal that lacked a lot of oomph, for lack of a better technical term. So I thought about doing the 150K, which is the green line, but that's still in a mostly linear portion, especially for the plate voltages I'd be running, which are supposed to be 115. So as we get into that, we're in the straight part of the curve. I didn't want to go back to 330 because that was too hot, in my opinion. So I ended up on 220, which is the blue line. You still got just a touch of curve right there at the bottom as they're going into linearity, but you're not way up here in the straights either. And for the record, I tried, so the yellow is 75K, and maybe I should talk about this a little bit more. I tried a 50K, which would give us a plate current reading of 6.4 milliamps, which is a little bit off the top of the chart here. And there's no point in graphing it. It's just a steep line that comes down across the tops of these straight lines. When I hooked it up, it made no sound. So I believe that is the saturation point. Could be the cutoff point. I'm still learning. But the point being that when the tube was biased this high up, it didn't work. There was no sound passing. So I didn't even bother going to the 75K, because once I hit the 220K and I kind of understood that I needed to come down this way, there was no point. So with 220K, right here, we've got a plate feed voltage of 320 volts DC. We've got our 220K plate resistor, which gives us, if you divide 320 by 220,000, that gives us 1.45 milliamps. I think it actually comes out to 0.00145, but you get the drift. You're smart, you'll figure it out. So 1.45 is right this point here, and our plate voltage over here is 320. So that's where we plot our line, is from 320 over here to 1.45. And that is called the load line for your 220K plate resistor in the 12AX7 preamp section of the 7247/ECC832/12DW7 preamp tube. That's a mouthful. Let's see what else. When I did have the 100K plate resistor in there, I noticed that it dragged down the 12AU7 triode. So I had 160 volts on the plate of the 12AX7, but the 12AU7 was dragged down from, let's go back over here, zoom back out just a touch. Oh, we can do the zoom in. It should have been 215, and it was down in like the 160 range. And that low of a voltage on the plate of the phase inverter caused the phase inverter to brown out and get dirty. So it was distorting at lower volume than even before I had made the change of the 300 to 100K. One thing I did do while I had the 100K plate resistor in there, I started looking at the cathode resistor and wondering what it would sound like if I bypassed it with a coupling capacitor, or a bypass capacitor, an electrolytic. So I went to my parts bin and I grabbed myself a couple Sprague Atom 50 microfarad 50 volt DC capacitors. Oh, let's come back down here, please. And I bypassed the cathode resistor on the 12AX7 side of the first preamp tube. And wow. I mean, I played with bypass capacitors before in tube amps of all kinds, but the sound quality improved so much that I put that in there and I stuck with the 220K. But there was still too much volume. Great sound quality, but I couldn't crack the volume past, say, 2 or so before it was loud. And it didn't really get a whole lot louder by halfway. I mean, it got noticeably louder, but it just filled out the sound, and the room filled up with sound, which was kind of cool. But I needed to tone it down, and that was part of the problem I was having with the 330 or the 300K resistor in that first stage as well, was that there's just too much gain. Everything that comes through here hits that, and it's loud. It is loud AF, as the kids say. And by changing this resistor, because this plate is directly coupled to that grid through this wire here, changing this variable changes the current draw in this tube, which then draws down the plate there. So what I ended up with was the 220K resistor here, which brings this from 215 down to about 185. And that keeps it clean and lively and dynamic and detailed. But that wasn't all I had to do. I needed to address this front end here. So let me move the camera over to the amplifier and we will take a peek at what was done today. Bear with me here. I'll try to be gentle and scoot you all over. So we're looking at the input jacks from the backside and the volume control, which in this amp is a 250K linear dual gang. And what these resistors are, this is a voltage divider on each channel. It's going to be hard to see down here, but there is one resistor coming from the hot to the input of the volume pot. There's another resistor going from the hot to ground, and they are both 470K, so they're equal value, which means we are dumping half of the input signal straight to ground. So we're only getting 50% of what we feed to the RCA jack to the volume pot to turn up and down to the rest of the circuit. That change right there made all the difference, because instead of sending such a huge signal into the first stage of the preamp tube, now we're sending something way more reasonable, and the amp can breathe, which is probably the most important thing that happened today, was just the amp was allowed to breathe. And what that did was, it meant that all the dynamics are preserved, all the detail and the clarity. I wish that I could play some of the CDs that I listened to for you, but I'll get a copyright strike. Let me grab them. This was absolutely amazing today. Like, next level. I've heard this, I don't know, 40, 50 times at least. I heard details in this, background vocals, Bill Frisell doing just strange guitar work that I've never, ever heard before. Truly amazing. If you've never heard this, you owe it to yourself. It's from 2007. Likewise, on Eric Dolphy, the Illinois concert, there's only 2 songs on here that I listen to when I'm testing stereos, and it's Something Sweet, Something Tender, and God Bless the Child, which for the most part is just Eric Dolphy solo on the bass clarinet by himself. And there's a little bit of recording hiss, it's from analog tape, but you can hear the pads of his bass clarinet slapping when he flaps them shut. And there's one point where he hits kind of a squeak note and you can hear him laugh. I mean, it's amazing stuff. Like goosebumps down the spine. The other album that was just killing it today is The Flaming Lips, At War with the Mystics. This is just like a potpourri of great tones and sounds going into your head in ways that you might not expect them to. Square wave, sine wave, and everything in between. It's really, I love this album. I was lucky enough to catch him once on this tour at the Small House of Blues in Orlando. Really great show. Anyhow, I digress. As you can see in here, I have completely removed my preamp circuitry. I removed the plate resistor voltage feed for the preamp. I have not yet removed the capacitor, which was set up as a node for those plates. There's really no reason to keep this now. This resistor and this capacitor are no longer necessary. I'm still sitting at 150 ohms on the cathode bypass capacitor for the EL84s. What I may do now that I have the space here is to split this into two resistors, one for each pair, which would be a little bit better, reduce the amount of heat coming off this resistor because this one does get hot. Let's see, what else did I do? These are my cathode bypass capacitors for the preamp section. The way that the Dynaco negative feedback loop was set up, there was a silver mica capacitor coming from here over to here, and then that connected all the way down here to the, where are we? We'll try that again. There was a silver mica that went from here over to here. This brown wire here runs all the way down to the cathode of the 12AX7 side, and there's the same thing over here. I don't know if you can see that, but it runs from here all the way up over to here. Yeah, you can. So this is the positive side. This is a ground connection right here. You can see the tab down there that goes to ground, and the same over here. There's a tab that goes physically to the chassis. So it was just a very convenient spot because it's so crowded down here. I was going to have a tough time fitting this capacitor from that terminal down there to this terminal right here, which is about a ½ inch maximum. And the capacitor is closer to an inch in length. So I just didn't want to mess with that. I already had this wire attached, so why not take use of these terminals and all this free space up here? It doesn't make any difference as far as noise goes. So that's what I did. Let's see if there's anything else. We talked about the power supply box. If you want one of those for your vintage amp or for your Hammond organ or for your vintage studio gear, definitely feel free to get in touch through my website. I don't always check my YouTube messages, but through the website, send me an email. I will get back to you. Let's talk about how I came to the conclusion that I needed a bucking transformer and kind of where those ideas came from. Let's get you back over here. I am not a genius or an Einstein in any way, and I stand on the shoulders of people that are much more educated than myself and have already been there and done that. One of those people recently is Merlin Blanco, sorry about that, and his book, Designing Power Supplies for Tube Amplifiers. He also has two other books. One of them is Designing Preamps for Bass and Guitar Amplifiers, and the other one is Designing Preamps for Hi-Fi Stereos. I don't have the hi-fi stereo book. I do have the guitar and bass preamp book, and that's actually very good. So here we go on page 258. I always use $1 for my bookmark, by the way. It guarantees I'll come back to the book. Chapter 10.1, Primary Side Voltage Control. He's got a picture here of basically a filament transformer or any ordinary power transformer wired as both a buck and a boost, and the only difference really is the polarity of the secondary side. Definitely worth looking into this book. I think they're about $45, and it's already paid for itself. Really great resource. Let me get one other schematic for you. If you can just hang on one moment, I'll be right back. thought I had the printout handy, but the other resource I used was from Rob Robinette. He has a device that he calls the Buck Minister, and it's a bucking transformer that has a couple outlets on it, and I think there are switchable voltages on one of them. So I ended up going to both of those resources, and I came up with something that was kind of in between all three of them, and that's the power box that I showed you today. Oh yeah, there was one more thing. Let me see how I can do this the best way. Got to rotate you guys just a little bit. I may have talked about the fact that I'm in the process of rebuilding my ICO signal generator, my 377, which runs on vacuum tubes. It's been a little bit of a challenge. I've recapped every bit of it, all the bypass capacitors and electrolytics. I just ordered all replacement resistors. Not that every resistor needs replacement, but some of them are drifted more than 20%. So I'm just going to go ahead and blueprint the whole thing. Well, I guess since I'm talking about it, I'll show you too. The 6X5 rectifier in that actually had a crack in the glass. It was operating in such a way that when you first turned it on and the glass was cold, see that fracture right there that comes all the way down to the side there and down? When the glass was cold and you first started the ICO, the waveform would be distorted. There'd be a lot of fuzz on it, and it was something to do with the rectifier. I don't know if it was AC coming through or just poorly rectified DC is my guess. But as this envelope heated up, the molecules in the glass would swell, and the material would swell, and it would close up that gap, and it would work fine. This tube has not actually failed. It still works. It just only works when it gets hot, which is about 3 minutes or so. But I thought that was really interesting. I've already replaced this. This is going straight into the trash. But I wanted to save it and show it to you guys first. It just went in the trash. The other thing with that ICO, this is the choke. See those laminations in there? Those windings? Yeah. Technically it still worked, but I replaced it with the Triad C24X. Exact same specs, everything's cool. But unfortunately, after doing all that work, I still had a problem with it. A little bit of jitter in the trace. So I'm going to replace some resistors and see where it's at. I've got some new 6K6 tubes. I think I got a 6SJ7 WGT to replace that first triode and just take a look and see what happens. I'm confident I'll get it, but right now it's still in an inoperable state, semi-inoperable at least. So what I did was I went on to eBay, found myself a smoking deal on a BK4011A function generator. So let me turn this up some and we'll get a little better look. There we go. I don't know exactly when this thing was made. Probably, I'm going to guess 90s just based on the display and the plastic. But as you can see, that wave is stable and the frequency counter matches the oscilloscope. Like, this is solid. This was one of the best $50 purchases I've made in a long time. So now I have a stable waveform for the input. I've got an oscilloscope that's reading it for the output. And I got a couple 100-watt 8-ohm power resistors that are already hooked up to banana plugs. So at this point, I'm ready to inject signal into the stereo and see what comes out the other side, which happily coincided with getting the voltage divider set up and getting myself where I'm very pleased with the sound. You know, we're going to see what happens. But I just wanted to give you guys an update. It's been a while. I've been lost in the weeds. I've been building guitar amplifiers. I've been kind of all over the place. But I was back on this project today and just want to share an update. Thanks for watching. If you have any comments, steer me right if I'm saying something wrong. I appreciate it. Have a good day.